Hello students, welcome to your section 7.3 video. Today we're going to learn a new method of solving systems of equations. It is called elimination and it is fun and satisfying, so get ready. The essential question for today is obvious. Other than substitution and graphing, which are the two techniques that you've already learned, what other techniques can I use to solve systems of equations? So let's take a look. I meant to look up a meme, but I could not find any interesting ones. So anyway, example 1, solve. So previously, we discussed the fact that you could graph these and solve for the intersection point. We also discussed the fact that I could isolate one of the variables and substitute it into the other equation. However, doing a substitution step here is going to be a little challenging because look, every single variable has a coefficient, which means that if I try to isolate one of the variables, eventually I'll have to divide. For example, let's say I'm trying to isolate this x. I would subtract 3y to the other side, but then in order to isolate the x, I'd have to divide by 2, and that's going to leave me with a lot of fractions, which is undesirable. So it'd be really nice if I had another method of solving these equations, and luckily I do. As it turns out, these equations have something very special about them. Look, this 2x and this negative 2x are lined up to eliminate. And I can eliminate them by adding the two equations together. So as it turns out, if you have two equations, you are allowed to add them together and combine the like terms. And this is a legal math thing to do. I'll let you figure out why if you want to. So when I add these two equations together, 2x plus negative 2x gives me 0x. Or in other words, the x's eliminate, leaving me with no x's. And really, I don't even have to write the 0x because 0x is just 0. Adding up the y's, I have 3y plus 5y is 8y. Then I have my equal sign. Adding up the numbers, I have 11 plus 13 is 24. And take a look at what happened. Now I have an equation with just one variable, which is very nice indeed. I can simply divide through by 8 to find that y equals 3. Don't forget that I also need to find x, but at this point I can just substitute my y back into one of these top equations and solve for x easily. So if I plug y back into the top equation, I have 2x plus 3 times, instead of y, 3. I typically do not record videos at school for that very reason, but today is a special exception. Anyway, 3 times 3 is 9. I would subtract 9 from both sides, so 2x equals 2. And dividing through by 2, it looks like x equals 1, which means my solution, the xy pair, that's the intersection of these two lines, is 1, 3. Remember, you can always plug back in to check to see if things work. For example, 2 times 1 is 2, 3 times 3 is 9, 2 plus 9 is indeed 11. Over here, negative 2 times 1 is negative 2, 3 times 5 is 15, 15 plus negative 2 is 13. So my answer is definitely correct. And I got it by adding my two equations so that the x is eliminated. Let's take a look at another example. So we know here that, well, right now there's something wrong. All right, sorry about that. I fixed the mistake. Instead of a 5y in that first equation, it should actually be 3y. Now, we know that on the last slide, what I did is I added the equations together and a variable eliminated. Take a look at what would happen here if I added the equations together. If I go 4x plus 5x, that'd give me 9x. And then if I go 3y plus 3y, that'll give me 6y. If I add 2 plus negative 2, that does eliminate the number, but I'm still left with an equation with two variables, and that is not what I want. Luckily, not only can I add equations together, I can also subtract equations. So here I'm going to want to subtract because what is 3y minus 3y? Well, that would be 0y. So you need to choose between addition, like we did in number 1, and subtraction, like we can do in number 2, and you need to pick whatever is going to eliminate the variables. Clearly here adding did not eliminate, but if I subtract, then I do eliminate. So I'm subtracting the equations. The y's eliminate, they cancel because 3y minus 3y is 0y. That leaves me with, let's see, 4x minus 5x is negative 1x. I have a 0y here that I can basically ignore. Be careful when you're subtracting. I have 2 minus negative 2. 2 minus negative 2 is the same as 2 plus 2. And so my answer is 4. So be careful about the double negatives. Like we said, the 0y I don't even have to write. And to solve for x, I can just divide through by negative 1 because x is the only variable left in the equation. So x is equal to negative 4. Let's plug this x. I'm feeling like plugging it into the second equation. So 5 times negative 4 plus 3y equals negative 2. Plugging it in here allows me to solve for y. I have negative 20 plus 3y equals negative 2. Hopefully you're getting comfortable enough with equations now that you don't have to write the steps every single little detail. For example, here, I'm adding 20 to both sides. So 3y equals negative 2 plus 20, 18. Now I can divide through by 3, so y equals 6. And my point is negative 4, comma 6. Nice. All right, one last example. Here's another thing that you might see. These equations are not set up to eliminate. Look, in the previous 2 slides, my x's were lined up, my y's were lined up, my equal sign were lined up, my numbers were lined up. Here, though, I have an x with a y, not like terms. My equal sign is here as opposed to being lined up with this equal sign. The point is, things are not lined up. And if they're not lined up, I'm not going to be able to combine the like terms properly. For example, what would be 8x plus 4y? It's not something weird like 12xy. They're not like terms. So I would have to just write 8x plus 4y. And that's just not right. So the point is, I need to make sure that I align my variables before I eliminate. For example, here, I need to get the x and the y on the same side in both equations. This top equation looks good. This bottom equation, though, x and y are on opposite sides. I can put them on the same side, though, by subtracting 3x. This, by the way, is the exact same thing we did to get standard form, if you remember back to lines. Put the x and the y on the same side. So I have negative 3x plus 4y equals 14. And let's just rewrite the top equation. I didn't do anything to it. I can just rewrite it. Okay, now everything is nice and lined up. The x's are lined up, the y's are lined up, the equal signs, the numbers, everything is lined up, so I can either add or subtract. So let's think about whether I should add or subtract. Well, clearly here the y's are set to eliminate because I have a negative 4 and a plus 4. So think about it. Is adding going to eliminate them or is subtracting going to eliminate them? I think adding will be the eliminating step, because negative 4y plus 4y gives me 0y. So I'm going to add my equations together because negative 4 plus 4 is 0. Doing the rest, 8x plus negative 3x is 5x. I have this plus 0y equals negative 4 plus 14 is 10. I don't need to write this 0y, it's just 0, and 5x plus 0 is just 5x. So dividing through by 5, x would clearly equal 2. Plugging this back into literally any equation I want, let's just do it in the top one. I have 8 times 2 minus 4y equals negative 4. This is going to be 16, so if I subtract 16 from both sides, I get negative 4y equals negative 20, and dividing through by negative 4 gives me that y equals 5, so my ordered pair is 2, 5. All right, I am all done. Summary. All you have to do to eliminate a variable is choose whether to add or subtract. Notice, if there was a minus sign and a plus sign, I chose addition. But if the sign was the same, so positive 3y and positive 3y, I chose subtraction. So make sure to choose the correct operation, and then you can eliminate the variable and then you're done. Sorry for my hoarse voice today. I feel like it affected my humor, but hopefully you made it through the video nonetheless. Cheers, and see you tomorrow.